Hello viewers, welcome to this discussion. Still on differential calculus, we have these two problems that we are supposed to solve or find their gradients by simply using the first principle. So the first principle is a method of differentiating where you have certain variable of h approaching 0. So here we say that find the gradient function using the first principle. We have the limit as h approaches 0 of f of x plus h minus f of x divided by h. So this is the formula that you are always supposed to use when you're differentiating a function using first principle. So here we have this function, which is, so our function here, our f of x is equal to x to the power 3 plus 5. So here now we have the numerator part in the one which we have there down as our denominator. So we have f of x plus h and f of x. So when it comes to f of x, there's no problem in terms of substitution. We just get the function the way it is and take it here where we have f of x. Now the trick part is where we have f of x plus h. So when you have f of x plus h like that, what you are simply supposed to do is, from the function that you are given, look at where x is, and wherever there is x, you are supposed to add h, and the degree or the power of that same term has to be maintained. So looking at what we have here on the function, you have x to the power 3 plus 5. Substituting f of x plus h means that we are going to get x plus h, which is this part, which is to the power 3, meaning that even you have to the power 3, then plus 5. So the 5 won't be affected here because there is no x to it, so you can't add x plus h to 5. So this is now what we're going to substitute right now, f of x plus h. So this would give us the limit as h approaches 0 of, so where there's f of x plus h, we're going to put x plus h to the power 3, then I'm going to say plus 5. Then from there we're going to say minus. So what is f of x? We substitute with the function. So this is x to the power 3 plus 5. Now, because of the negative, and when these two multiply, this will simply give us a negative like that. So this will all be divided by a variable h. Now, after this is done, you are simply going to say that the limit as h approaches 0. So we are then going to expand x plus h outside brackets to the power of 3 using the binomial theorem. Now here you can use the binomial theorem, you can use the Pascal's triangle, or you can just use the algebraic method. So we're going to go with the Pascal's triangle, where we're going to have x to the power 3 plus 3x squared. So here we have x to the power 3 plus 3x squared multiplied by h plus 3x h squared, then we say plus h to the power 3 like that, then we say plus 5 minus x cubed minus 5 divided by h like that. Then if this is done, we're going to have a limit as h approaches 0 of, so x to the power 3 will cancel with x to the power 3, 5 will also cancel with 5, so mean that we only remain with terms that have h in them. So we have 3x squared h plus 3x h squared plus h to the power 3 over h like that. Then after this is done, if you look at the numerator there, we have each and every part or term having h in it. So the h will be factored out. When it is factored out, we're going to have something like, so I'm going to take this information on the other side. So I'm going to have the limit as h approaches 0 of, so when I factor out the h, I'm going to have h. Here I'll have 3x plus, there I have 3xh plus h squared like this over h. So the h and the h will cancel, mean I'm going to have the limit as h approaches 0 off. So here I'll have 3x squared plus 3xh plus h squared. Now, since I don't have h down there, so mean that wherever there's h, I can now peacefully substitute with the 0. So this will give me something like 3x squared plus 3x0 plus 0 squared. So when the 3x is multiplied by 0, I'm just going to get a 0 here to just be 0. So my gradient function for this given function using the first principle will give me 3x squared as my derivative. So this is how you solve the first problem using first principle. Now we'll go to the next problem. So now I have the second function, which is 1 over x minus 1, which I'm also supposed to find its gradient using the first principle. So what I'm going to do is, I'm still going to say that the limit, like what I did with the first problem, I'm going to say the limit as h approaches 0 of. So here, substituting where there's f of x plus h, I'm going to have 1 over x plus h minus 1. Then I'm going to say minus 1 over x minus 1. Then I'm going to divide everything with h, like that. So, if you look at this one, it's a bit having more work to be done. So, we're going to simplify it. What we're going to do is, I'm going to solve the numerator on this part, which is 1 over x plus h minus 1 minus 1 over x minus 1. So here, given this, I'm going to find the common denominator. So my common denominator, or my lowest common multiple, will be x plus h minus 1 to multiply with x minus 1. So when I divide x plus h into what I have, I'm going to get x minus 1 minus this, which is x plus h minus 1, like that. So when I work this out, I'm going to get x minus 1 minus x minus h plus 1, then divided by x plus h minus 1 as my lowest common multiple, and x minus 1 also as my lowest common multiple. So the negative 1 and the 1, these will cancel. The x and the x will also cancel, meaning that I'm going to get negative h over x plus h minus 1 and x minus 1, like that. So this is then what I'm going to substitute on my numerator there. So I'm going to get the limit as h approaches 0. So there I'll have negative h over x plus h minus 1 multiplying with x minus 1. So this is divided by h. So when this is the case, I'm going to have something like, so I'm going to multiply both the numerator and the denominator with the lowest common multiple of the numerator. So I'm going to get negative h over what I have there, which is, so this is simply the limit as h approaches 0 of. So when I multiply the lowest common multiple with what I have here, this will cancel with what I'm going to multiply with. So I'm going to get negative h over, down there I'm going to have h multiplied by x plus h minus 1 multiplied by x minus 1, like that. So this would then come out to be the limit as h approaches 0 of. So h and h will cancel, meaning I'm going to get negative 1 over. So this will be x plus h minus 1 to multiply with x minus 1, like that. Now, after this is done, I'm then going to substitute wherever there's h with a 0, meaning I'm going to get 1 over. Now once I substitute with the 0 where there's h, my limit will be cancelled. So I'm going to get x plus 0 minus 1 to multiply with x minus 1. So this will be negative 1 over x minus 1 multiplied by x minus 1. So this will give me my gradient function to be negative 1 over x minus 1 squared, like that. Thank you very much for watching this video.